In this video, our goal is to take down the notes for the parabola, so you will want your note sheet out now. If you need to pause the video so you can get that out, do that. But we're going to take down the notes for a parabola. You've already seen a parabola that hasn't been shifted, but now we're going to look at one that has been shifted. So to start with, the parabola, of course, will have two potential directions, up and down or left and right. And so the standard form of the parabola that's facing up and down, the equation will be x squared equals 4py. But if we have a shift, now we have to shift and adjust our x and our y values. So what we do is we have y minus k and x minus h. So this is a very different form than what you're used to from Algebra 2 and even from earlier this year. But this form, it just fits with everything we're doing with parabolas, and it matches the definition of a parabola, which is why we're going to use this form. Now the equation for a sleeping parabola, like we've called them in the past, or a parabola that faces left and right, is going to be very similar, but now it's y minus k squared equals 4p x minus h. So we have these two forms of the equation. In both cases, our vertex is at hk, so that's consistent with h comma k. That's consistent with what you did with parabolas earlier in the year. The focus, let's first talk about this directrix and the p-value. The p-value is really about the distance to the focus and the distance to the directrix. So for both situations, p will be the distance to the focus or the distance to the directrix. So on the left one, the vertical directed parabola, the directrix will be down p. So what we're going to have is the equation y equals k minus p, because the equation of a horizontal line, since we're up at x with the vertex, we're going to go down p to get to the directrix. That will work even when p is negative. It's going to be just minus a negative number, and it'll still show you the directrix. The focus, since it's also in line, it's still going to be at h, but then it'll be k plus p for the y value. So that's how we're going to get our focus and directrix for a normal upward-facing parabola that is actually a function. So all that should kind of fit with what we've done in the past. The other one, of course, now we're going to be shifting left and right to find our focus and our directrix. The distance will still be p to the left and p to the right. So the focus will have a very similar look. It will be at h plus p comma k. So instead of going up and down, we're just going to go to the right p. We're going to add p on. The directrix will be very similar now, and notice it's an x equation, and it's going to be h minus p, because we're going to go back p. So the only other thing that we need to understand is this latus rectum. That's the line that goes from, so here's how it's spelled, the latus rectum. It's a line that goes from, it goes through the focus with endpoints on the parabola. The length is always going to be 4p long. And we'll call that the absolute value of 4p, so even when p is negative. So what that means, if you want to add to your picture, is that the distance from here to here is 2p. It's half the distance, because altogether we want this whole thing to be 4p. So maybe on one picture you denote that this whole length is 4p, absolute value. Same for both pictures. The definition of latus rectum is the same for both pictures. But it will always go through the focus and have two endpoints. So those are going to be your key points. So real quickly, I'll highlight off what you'll need to graph these. You'll need the 2 points that are on the curve, the vertex, the focus, and the lattice, and the directrix, excuse me. So notice it's 4 points and then that one line, the directrix. So it's comparable number of things that you'll need to graph it. The directrix is a key part for applications, as is the focus. So while they're not on the curve, they help us understand the application. So you will want to know how to graph those. We're going to look at one example where we have to complete the square. So this example here, you'll want this down in your notes if you're one that likes to take notes, or just listen in to some of the hints that we have. So first, when we're dealing with parabolas, we first want to try and figure out which parabola it is. So we see the y squared, and notice that x is not squared. So that tells me right away it's going to have the following form. It's going to be a sleeper parabola, a horizontal parabola instead of a vertical one. Now I'm going to complete the square just like I always do, but before I do that, I'm going to move everything else to the other side because I know in my standard form I have y squared, the form y minus x squared on the left, and everything else is on the right. So now I'm going to complete the square here, and it will end up being y plus 1 squared. And what's created as my perfect square is a 1 to complete that square, so I have to add 1 on the right to complete and keep it balanced. Now, I'm not really in my official form yet. Notice the other thing that you need is that you need to have this coefficient out in front. Notice on the left on the equations here. And you want x minus something on the inside. So in order for us to see the center, or the vertex in this case, I need to factor out whatever is in front of x. So in our case, it's going to be negative 12. So my left side will stay the same, but I'm going to take out negative 12, and I'll have x minus 2. Notice I took out negative 12, so it ended up flipping the 24 to be a negative 2. So I now have my graph in standard form. I could go even further and change 12 into 4 times negative 3, because now I see my p-value of 3 or negative 3. So 3 will be my distance to those things. Since it's negative, this parabola will actually open left to the negative direction. So whenever p is negative, you want to think of pointing your parabola in the negative direction. So if I were to now graph this, I have everything I need to graph it. I would have my center, or my vertex in this case, would be at 2, negative 1, so over 2, down 1. That's my vertex. My distance of 3 here, or negative 3, tells me that I'm going to add on negative 3 to get to my vertex. So in this case, I'm at my vertex. I'm going to add on negative 3 to get to my focus point. So my focus is in here. And I'm going to subtract off negative 3 to get to my directrix. So my directrix is over here. So the red point, remember, is your vertex. And then I went 3 in both directions because of my p-value. The last thing I'm going to do is use the value of 4p, which, go back up to your original, it was 12. But remember, we take the absolute value of negative 12, which is positive 12. So that means that my latus rectum, remember, is a distance of 12. So I'm going to now go 6 up and down because I have to split it in half, because the focus will split that latus rectum in half. So I'm going to go up 6. So 1, 2, 3, 4, 5, 6. That's one other point on my parabola. And I'm going to go down 6. And I'm going to have another point on my parabola. So now I have 3 key points on my parabola. 1, 2, 3. And I'm going to sketch it. And I'm good to go. Okay, so that last piece, the latus rectum, is just helpful to draw in the curve. So that distance there was 12. 6 up and 6 down, because 4p, the absolute value is 12. So you're getting practice with this. Remember, check your answers in the solution manual, work together. Try and make as much sense of this as you can. You're not graphing too much today in your So at this point I could finish it up and write it fully x minus 2. And that would be an equivalent statement, and then of course it'd still be y plus 1 squared. So this is my standard form. That's what you're doing for some of the problems as noted on the assignment sheet. You're simply writing it in standard form. It is a good idea to pull out the 4 because you'll need that 3, negative 3, to help you find the graphs. We'll work more on the graphs after you watch the next video. You'll see more on how to graph this and how to incorporate the lattice rectum. So bring those questions in, write them down, do your best, but be sure to watch the video for tomorrow as well.